Hello people. Hello people. I just mute myself. That's funny. I was mute myself. So good afternoon, good morning, good night, wherever you're in the world and your time zone is. I'm seeing people in Vancouver, Egypt, India, Pune. This is your city, no, Vedant? Is this your city?
Yes, it is. Pune is my city, yes.
Hello, Vedant.
That's where I live.
How are you?
Hello, how are you?
Good.
Yes.
So nice. So who is Manas? Manas Dalby is also from your city. Sidharth, where are you from?
Hi everyone, I am from Haryana, India.
And you, Victor?
Well, I am in the center of Spain. Well, north, a bit in the north.
You're in a place that we call the best wines in the world.
It is.
La Rioja.
It is.
Well,
Yes. Vedant and Sidharth, do you know Rioja's wine?
Oh, we don't drink.
They drink Coke. Don't you see? They are young guys. They drink Coke all day long. Or beer.
I've just become the legal age, so
The legal age in India. In US, you have to be
yes.
21 to have alcohol. For example, let me ask Ryan. Ryan, you're in Canada. Canada, what is the legal age to drink alcohol? First, we have to wait for a few seconds till the YouTube goes and Ryan listens to our question. But it depends on the place of the world. So again, thank you very much for staying with us today. Today is a pretty intense day. You can note that we are approaching the GSoC final dates. We are in the program, but we have to fight for an intern. 19. So no, not 18, no 21, but 19. You still cannot drink beer in Canada. This is
No, but I'm 22, so
22. Sorry, I think you were. You're an old guy. Nah, you can drink in all the world. Okay. It was my fault. So I was saying that first of all, thank you, mentors, for being here. Vedant mentor and Victor mentor. And you don't are a mentor, Sidharth. You're still a contributor. You're a good contributor. You also were winner last year of Game Face contest. So congratulations. But thank you also for sharing today your knowledge with the community. So I'm gonna stay 1 second. I need to drink. I still have my throat a little bit out of order. So let me share the slides. We are now both speakers on the slides. And the agenda for today is a special one. As you remember, also you have to take a look at this year is the 20th anniversary of the Google Summer of Code program. So also we can call them also, we can say to them also congratulations, 20 years. Google Liquid Galaxy project has been in GSoC since 14 years ago, but this GSoC is 20 years old. So today's session is for talking about artificial intelligence. This session is included in a session that Google is doing a special I'm seeing some icons not good on the streaming. Google is doing a training sessions about artificial intelligence for the Google developers communities. They call these sessions Build with AI, and this session for today is for the Liquid Galaxy, but it's on the same thing. You know that we run this Liquid Galaxy community together with the Google developers group JADA, and so we talk a lot about Gemini and Gemma. And always the same stuff, guys. During the Ask Me Anything, at the end of this streaming, we will be answering your questions. Be polite and respectful. And wherever you want, you can start writing your questions in the chat window of the YouTube. We are not going to the Discord. We are doing that again in YouTube, just for the speed of the answers. And you can write your questions now during the streaming, and then will be answered at the end. And also, as I was, I need 2 volunteers to take notes on the session. So please, if there are 2 volunteers explaining on the YouTube chat, and one of you open a doc and share with your colleague, and later at the end of the session, share the notes with me just to publish them on our Liquid Galaxy site. So Manas volunteers, we have the first one. And Pablo also volunteers. Thank you, Pablo and Manas. You two are the team for notes today. Thank you very much. So what else? Victor, or Flutter expert. I still don't say Google developer expert, but this will be soon. Or Flutter expert, was mentor last year and he's going to be mentor this year. Vedant, contributor last year and mentoring this year. Sidharth, winner of the K-Face Context, wannabe contributors this year. We decide the best for you, Sidharth, but remember, you still have to fight against all the other contributors, because this is I don't want to call it a fight, but you have to be doing what you're doing today, and other of your colleagues, contributors, doing collaborations with the community, okay? And me, I started with other Andreu and Ben. In the 2008, I started this thing, and I'm still here. So, agenda for today is this stuff of the Build with AI, Gemini and Gemma. A few slides talking about this crazy time we are living in the artificial intelligence years. Talking a second about our artificial intelligence server, and then we have different talks from Vedant, Sidharth, and Victor about integration in Flutter or on other questions. And the questions will be at the end. So this is going to be fast. We are thinking about doing stuff for Google Summer of Code, so we can develop things for whatever we want, but it is nice to work with Google technologies. But remember, we can always work with other technologies, open source technologies, not closed. So we have this thing of Gemma. Gemma is the large language model that is open source by Google. And then we have Gemini. Gemini is not open source. Gemini is an API-based or Google Cloud Console API open the location on the world. For example, for Victor and for me, we have to access Gemini through the Google Cloud Console. We don't have access through the API, but you too, Vedant and Sidharth, plenty of people that are listening to us, they have direct access to the API, and at some moment you will be explaining this. So if we are going to do things with Gemma, that is the Google open source model, we have to run it in our Docker-based artificial intelligence-based server that we have in the Liquid Galaxy. I'm going to talk a bit about this in a second. And also we can run other large language models that are open source in our Docker-based server. I remember that Vedant will be talking about the integration that he did last year with the BARK, B-A-R-K, open source model for synthesizing voices. So what else? We've been doing for years things with artificial intelligence. We've been doing things with TensorFlow. We've been doing many different projects. But last year, the year became crazy when the people of the ChatGPT OpenAI launched their chat box suddenly. And then this 2024 is going to be more crazy. Every day there are announcements. I don't know if you are following, but this is totally crazy. And it's very funny. So today is a very first introduction, but we will have more in the upcoming days. We'll have another one with Alfredo, or Google Developer Expert in Flutter, that he will be doing a special session in how to integrate Gemini with the API of Google, but with a special workshop that he's still finishing. And it will be nice. It will be in the future. Today, Victor and the other ones will be explaining to you a bit about this API access. So the point is that the world has become crazy with the AI. Google is also, I will say, crazy about AI, and we are not doing that stuff of the build with AI campaign. So this is the point. What else? Just a bit about the Docker server. We started last year doing artificial intelligence projects with a server base with Linux and Dockers. This server runs in our own rigs. So then we have another machine that the one we have at the Liquid Galaxy Lab is these specifications. Those are not the most beautiful specifications in the world, but at least this is one machine we have dedicated for this. It runs on Rocky Linux version 9.2 with 1 terabyte disk capacity, 16 GB of RAM, one NVIDIA, all NVIDIA, we have to say, and a good CPU. Not new at all, but very good. So all you that develop for models running against the open server have to remember that this is the specifications we have. I mean, for example, if you want to run I will say a very large model that needs a lot of RAM, VRAM on the graphics card, we will not be able to do that. So remember that we have these specifications to run the models. The ones that are open source and we run inside our network. The ones that this year will allow to do, like Gemini, that you just have to have access through the API or through the Google Vertex API in the Google console, that's not a problem because those are in the cloud and are enormous. What else before we start? Nothing else. So at this moment, I'm going to pass the word to Mentor Vedant, and then Mentor Vedant, you can start talking about presenting your presentation, okay? You can do it.
Yes.
And Sidharth and Victor, if you want, you can switch off your cameras. You can start.
Okay, so the presentation is not visible.
Yeah, the presentation is not visible. Let me try to change this. I was thinking in doing one stuff, but you're right. 1 second. I'm gonna change it. Sorry. We are live, but this is live. 1 second. 1 second. I'm back. I'm just putting the animations for 1 second.
Sure, take it in. Sure. Got it. Yes, it's visible. Okay. So should I start?
1 second.
Okay.
Now, screen is shared, and you can start your presentation. And whatever you want, ask me for changing the slides.
Okay. Hello, hola, guys. So I'm Mentor Vedant, and our goal for today in this session is to teach you how I integrated the AI models last year. As a contributor, what I did was finally I integrated an audio generation model, but I also tried to integrate an LLM. So I also know the process for the LLM. So I will get you into that as well. Okay. So let's start. Could you go to the next slide, please? Okay. So this is the agenda. First, I will teach you how I integrated the audio generation model into my Android application, and then we will get into how you can generate and you can integrate an LLM into your project, because this year the AI projects are mainly on LLMs. Okay, so last year mine was audio on audio generation. Next slide, please. Okay, so it began when mentor Andreu sent me a message with a GitHub repo about Bach. So Bach is an audio generative GitHub repository. It is an open source audio generative model. What it does is you have to just give in a text prompt and it will generate an audio of it. Okay, and the audio there are many parameters which can be adjusted if you want to change the audio, the voice, or any other parameter, the speed, anything. So let's get into it, and how did I start integrating it and getting help. So as a beginner, could you please change the next slide? Okay, so as a beginner, the first step I did was get to the repository, go. I got myself enrolled in the community. Okay, I went in the Discord community. Luckily they had a Discord channel, and a lot of people there were very helpful. I'll show you the chats. I'll show you some chats, how people helped me, how I helped a couple of people. And the first thing which I did was using the documentation and the community. What I did was I tried to run the model locally. By locally, I mean I had a WSL. WSL is like Windows system, a subsystem for Linux. So it basically is a virtual machine, but only with a command line. So I tried to run it locally, and luckily it ran. Okay, not the large model, but the smaller model, because these kinds of things take a lot of space and computational resources. And my laptop wasn't that strong. Okay, and I'm pretty sure yours is also not, because it really takes a lot of GPU, maybe 16 GB of GPU or something, if you want to run the large model. I had 4 GB of GPU. I'll first of all tell you the specifications of my laptop. It has 24 GB of RAM, 16 GB of GPU, which is NVIDIA GTX 1650, and 1 TB of storage. That's it. That's what I did. And if the model runs on your computer, then the AI model in the LiDAR lab, where you have to finally run your model, the specifications will match. They will likely be very relative. So that's how you can approximate whether the model will run on the LiDAR lab or not, LiDAR lab AI server or not. Okay. So next slide, please. Okay. So one thing which is extremely underrated is people dive into the documentation first and not go ahead and get themselves familiar in the community. Try. Let's say if you get some errors, you can just search for those errors in the Discord channel, or you can ask questions. You can ask other people for help. If there is a person, let's say, you can message him directly. You can DM him with your problems. People help. Okay, this is an open source community, and people help. That is the meaning of open source. So I went into the community. I asked my questions, and guess what? A lot of them were answered. Okay, so thanks to these people were very experienced with the model, and as I was new to the model, the only people who could help me were these people, because they have a lot of experience, right? So take advantage of it, ask them questions. Next slide, please. Okay, so while running the model, I had a few errors. Let's say, let's get into this error. Okay, so in this case, what was happening was my inference was running, which means my GPU LLM instance was running, but it was not using GPU. It was using my CPU. Okay. When I was running it on WSL, it was running on GPU. But when I put it into a Docker, when I containerized it into a Docker, it was not running on GPU. It was running on CPU. So how to do it? How to solve it? I didn't know any solution for this. So what I did was I simply searched for the error warning, okay, in the Discord channel, and guess what? There were answers already to it. So a lot of questions are already answered on the community. That's the reason we also encourage you to ask questions on the community and do not DM the mentors directly. This is exactly the reason, because new people come into the Liquid Galaxy community, and let's say they don't know how to fix a Liquid Galaxy VM error, then uh, uh, which one is better approach? Which one is the better approach? Should they directly search for the error in the Discord community, or should they DM a mentor? Definitely search for the community, right? Next slide, please. Okay, and this is what I was talking about. So my questions helped other people as well, because I asked some questions. Okay, they were answered by a few experts who are already pretty good at running the model, and they answered my questions. And other people who were new to the community, they were helped as well. They solved their errors. They got their questions answered. Everything. Could you please go to the next slide? Okay. And the next step I did was I forked the repo and I made a Flask API. Why? Because the model was running locally, and but I had to provide prompts manually. So what I did was I made an API, because I had to containerize the LLM and I had to containerize the audio generation model and the LLM. Okay, so I had to containerize the audio generation model and the API into a Docker and then send it to the LiDAR server, LiDAR Lab AI server. So I did the same locally first in my system, WSL, and then I had to send it. So the first thing on the list to check off is to make a Flask API. So I used Python Flask because it is pretty good for making REST APIs. I liked it. I was comfortable with it. I have good experience in working with Python. So I use Flask API, but there are a lot of other things you can use. It is completely your choice. And as the model was in Python, it was very good to go with Python as well. So I made a Flask API. It was relatively easy because it was an open source model and I could dive into the source code. I would know which variables are getting which components. Next slide, please. Okay. Adjusted the model to generate an MP3 version of the audio instead of WAV, as it was not running out. Okay. So the one error, which is a big one, it would be a benefit for you as well if you're working with Flutter or any other mobile technology, is that sometimes what happens is in the debug version, if you get a WAV audio file from an API or anywhere, it will likely run in the debug version, but it might not run in the release version. Okay, on some devices it might. So if you want a definite result, if you want it to definitely run on all the devices, the thing you should do, the first thing you should do is turn it into MP3, because MP3 is better supported by Android technologies. Okay. Okay. So what I did here, I had to first I had made the API and I had to adjust the model in such a way such that it provides me a WAV file and not provides me an MP3 file and not a WAV file. Because the problem I was facing was, as I said, the audio was running on the debug version but not on the release version. So I converted it in the API itself and not on the mobile version. I converted it there in the backend itself and then took it on my mobile, and which was a pretty good approach, I would say. Next slide, please. Okay, the next thing you should do, which I did, was I had made the API. The API was completed. It was running properly on my WSL locally. The next thing I did was made a Docker file. So what is a Docker file? I'll just be very quick with it. Docker is basically a container in which okay, first let's understand the problem. The problem is that you have a model, you have an API. In my case, I had a model and an API and a few dependencies. I had a Python version, I had this version, I had that version, I had a Flask uh, dependency, and they were all of different versions. And it was working on my laptop, but let's say I send the same to Sidharth's laptop or Mentor Victor's laptop. It may or might not run. Okay, so what I did, the best solution to this is Docker. Docker is basically, Docker just gives you a container which is like a box, and you just have to put in the model, you just have to put in the API and all the dependencies there as well, and it will run the same way in any computer in the world. So it's as simple as that. And the Docker file, what it does is installs those dependencies, installs those files into the Docker container. So now that Docker is basically a small VM of itself, and it will run anywhere in the world. And it is very beneficial to us in the AI server in the LiDAR lab. Why? Because it keeps the projects separate, because there are several projects running on AI, and each one of them will have different dependencies. Maybe uh, let's say a contributor one needs a model using a Python old version, and another contributor uses a newer version, then they both should not get mixed. Otherwise, none of them will work. So the best thing is to use Docker. So I made a Docker file. Next slide, please. Okay. So now that I have Dockerized the model and the API, I uploaded it on Docker Hub. Docker Hub is basically the GitHub for Dockers. So it is like a complete repo. There are several repositories. It's like a registry, just like the GitHub registry. So I have uploaded my Docker Hub Docker there on Docker Hub. You have the link. Actually, it is right there in front of the screen. It's Vedant King /bug2, and there is a little description, and it also directs to the GitHub repo. You can go ahead, and if you are trying to build an API, then you should go ahead and check out how I've built the Flask API, and you can try to copy the same. You can't really copy the same. You'll have to make it different, but you can follow the same method to do it. What you can do is just not use the audio model and use the LLM, whichever you are using, and build your API around it. Okay, and as it is an open source model, hopefully what you will be doing is you'll be having access to the source code as well. So you'll know which parameters are being handled by which variables. So you can adjust it according to that. Okay, and if you want, you can download it as well. Docker, if you want to run the audio model on your mobile phone, let's say, then you can download it on your computer as well. I have the link, right? I have the link in my project description as well. Okay, and next slide, please. Okay, and documentation is very important. Why? Because see, now I've made a project. Now you guys are newcomers and you want to see what I have made, because the AI projects have come in recently, newer, and a lot of new wannabe contributors do not have exposure to AI projects and their integration into Android. And many of you are Android developers only, because most of our projects are on Android. So you have to bridge the gap by integration, right? AI and Android. So that can be done via the documentation of such AI projects. Okay, and this year we'll have a lot more AI projects, and I want you guys to please document it very properly. And there are a lot of things you should take care of. There is another meet which will soon be happening on this, hopefully, and you'll learn a lot from it. And making a proper documentation helps you a lot in your career journey as well. and for the Liquid Galaxy community as well. And if you want to present your projects around later on in your career, the best thing is to document it properly, because the newcomers won't dive into your code, they will dive into your documentation. Next slide, please. So now let's get into the general steps which you guys are going to follow. This is not me. I'm talking about you guys. I have done this because earlier the goal of my project was definitely run the audio generative model, but also run an LLM. I'll tell you the problem in some time why I couldn't run the LLM locally. Okay, but I tried to run it, so I know what the steps are. I know what steps you should take in order to run it, and I'll tell you the problem, what happened for it with my project, and what alternative did I use. So the first step is you should search for an open source AI model suitable for your needs. Now you have an LLM, right? I mean, for the projects this year, I'm sorry, yes, this year we will probably be using LLM for almost all the projects. So you can go to the Hugging Face website. It's like a registry, you can say, for open source models. So what you can do is this link. This link is very useful. You should go ahead and check out which are the best performing LLMs, and I'll tell you which one is the best performing LLM real soon. But you should go ahead and check out according to your needs. Why am I saying according to your needs and not just any LLM which is performing the best? Because sometimes you will only need data for a specific niche. Let's say, let's say you need data only for geography, because in my case it was that. So you only need, because geography doesn't change again and again, right? So you only need the Wikipedia data. So a model which is trained on Wikipedia data, that's it. You don't need other complexities, other data which will add in more complexities and make the size of the model larger, right? Because we have restricted computational computational power as well. Okay, next slide, please. So now that you have chosen a model according to your requirements, right? Okay, so okay, I was just looking at these multimodal, these different types of models, and we don't really need that. But this slide is basically for showing you that there are many models. There are 481,320, which is a pretty staggering amount. And there are different types of models. If you want to extract features, if you want to turn text into image to text, a lot of them. But our focus is on LLMs, which is text generation, right? So this was just to show you the staggering amount of models there out there, which are open source models, which you can go ahead and use. And next slide, please. Okay, so along with those models, which one is the best one, do you think? The Gemini model, definitely. So the Gemini model, okay, we support Google openly, right? So the Gemini model is really good. It is tried and tested. And I don't know about the future, about whether it will be paid or not. But as of now, there is a coming soon in the AIs on the website for the paid model, but there is a free model. I think I recently saw it. It was free, but there is a free tier. There were only like 60 queries offered per minute. I'm not sure if it will be maintainable in the long run. I think mentor Andrew would be the one you would be discussing that with later on for specific projects, which you will have to work with only with the Gemini model running on the cloud. I mean the Gemini API. Next slide, please. Okay, so now Google has launched Gemma open models. So these are open source models, unlike Gemini. Gemini is a closed one, but the Gemini is also based on Gemma. And now Gemma is a pretty extremely good model actually, because Gemini is one of the largest LLMs right now, which is very trending and very accurate. I mean, LLMs are not entirely accurate, but it is very accurate. And there are two models which are released. First is the 7 billion parameter models, and other is the 2 billion parameter model. Okay, so in the 7 billion parameter model, it is a good one, but the size. Okay, so the number of parameters just represent the complexity and the training data. Okay, so that is what adds to the complexity. So the larger the parameter of the model, the more computational power it will take. That's why we are preferring 2 billion parameters only. Okay, so that it can run on our computers locally. And I have seen a lot of examples on uh, technical influencers running 2 billion parameter open source models on their laptops. And I think the performance is pretty good, and also the responses. And Gemma is available on open source uh, registry Hugging Face as well, which I just showed you. So you can go ahead, try it out. I think there should be a link later on to the Hugging Face repository for Gemma, but if not, I will drop it later in the Discord. Just you can just ping me for that. Next slide, please. And this slide is basically to show you how many data sets are there. Okay, so let's say you take a model and you have a specific requirement, but there is no model specifically for that niche. So what you can do is just take a data set, okay, and of your choice, depending on your requirements, and run the model. So as a contributor, what I would do is I would just take the 2 billion parameter model of Gemma, and I have a specific requirement. Let's say again the geography example. So I would try to search for the Wikipedia data set or something like that, or something related to geography which has a lot of geographical parameters. I would I would fine tune my model on that data set. Okay, or definitely it will increase the size by a bit, but you'll have to adjust it so that it runs locally and does not take up a lot of computational power. I will be mentioning the configuration of the AI server in LiDAR, so you have to take care of that as well. Okay, I will be mentioning the specific, but there might be some upgrades I'm not sure about. Okay, but you will know when you will be dockerizing the model and sending it to the AI lab. You will be informed about any changes in the configuration of the AI server. Next slide, please. Okay. Okay. So you have taken the model. You have to adjust the model according to your needs. Fine tune the model on the data set. Okay. What you can do, you can refine the model for accuracy. Okay. And to suit your needs. Let's say if there are some questions, LLM is all about prompts, right? So let's say if there are a few prompts, some prompts which are not expected to be answered by your LLM, then you can just remove the data for those prompts. I mean, not train your model in such a way that which is supposed to answer those prompts, because you have very specific niche. Okay, so so you can do that so that the size of the model will also be decreased. Okay, because see, I'll tell you this in simple words. Okay, the more the parameters, the more the size and complexity of the model. Okay, so if there are less parameters, if there are very controlled parameters, the size will also be less and the model will also run smoothly in the AI server. Okay, increase accuracy, make the agent suitable for the personalized needs for your application. So Depending on your application, you have to fine tune your model. Okay. And consuming less resources, yes, because as of now, we are restricted. We're talking about the AI server in the LiDAR lab, we are restricted, but the only place where it should work, first of all, is the AI server. We do not care if it runs on your laptop or not. Okay, if it doesn't run on your laptop, you can maybe get uh, cloud on student credits or something. Just try to make it run in such a way that it might run on the cloud if you don't have a powerful enough laptop, but you have to make it in such a way that it has to run on the AI server in the LiDAR lab, because that's the final place it will be tested and then published. If your model fails to run there, then it is pretty much useless for us. Okay, because that is the place where it will finally be tested. Next slide, please. Okay, so these are some specifications, I would say configuration. Make sure it runs locally. Yes, make sure it runs locally, not only on your computer. As I said, the final testing and demonstration will be done in the LiDAR lab. Okay, when I was trying to run it, the LiDAR lab was using NV124 GPU, but we are not sure where, by the time you will be running your Docker, you will be containerizing your Docker. We don't know if that will be the same GPU, but you will be informed at the time, but we can never be sure about it. Maybe we get an upgrade, maybe we don't. It might be the similar one, right? So compared to GTX 1650, I'm laying down these specific numbers so that you can compare whether if it is running on your laptop and it is working, then should it or should it not run in the AI server like the lab. I mean, you can just get an approximate, an estimate from this, right? So that's the reason I'm giving you these numbers. Okay, and don't completely depend on it, don't be 100% sure, but I think you can be pretty sure in as to, I mean, you can at least get an estimate. Okay, not the complete result, because ultimately the best result is trying it out, testing it actually in the lab. Okay, the OS being used is Rocky Linux 9.2. Yes, at the time it was Rocky Linux 9.2. Hopefully it will be Rocky Linux 9.2 this year as well, probably. But any changes in the configuration will be informed to you. Okay, you can just maybe take a screenshot, maybe um, keep a tab on these specifications, and any changes in the AI server will be informed to you. Okay, if you have an AI project later on in GSoC, if you are a selected GSoC contributor, I hope you work hard, okay, and get selected. Next slide, please. Okay, build an API for it. Now that you've chosen a model, now that you've fine-tuned it according to your needs, now that you have made it use less computational resources, that it will run in the AI server. Now it's your time. Okay. Now it's your time to build an API for it, and you can use Nginx. Okay. I'm sorry, just a bit, just a second. Yes. So you have to build an API. In my case, what I did was I made a local API. There's no need for hosting. It will be made local, so there's no need for authentication as well. You can build an API using Flutter. Okay, I think just a second. Okay, I think there's a network problem. Sorry. Okay, I'm back. Okay, yes. So what I did was I made a local API. There was no authentication needed, so I didn't add any kind of authentication in there. And I use Flask, but you can use anything. You can use Fast API, you can use Django, you can use Starlet, anything you like. Okay, I do not know about these technologies in depth because I've not used them. Flask is my favorite as of now, but I I insist you guys also use Flask because most of the models will be using Python. So you can just use them. Otherwise, you can use any API building language of your choice or the framework. Okay. And your networking should be solid. Yes. Because see, a lot of time, I'll tell you a scenario. Okay. Let's say there is a model running on your computer, right? It is in your VM, right? But the VM is also in your computer and the networking is preset. Okay. But when it comes to proper hardware, like proper hardware, as in there is a literal server and literal switches, and the networking is being handled through those routers, through those switches, then it should be your networking should be pretty solid. That the Docker which is running in the AI server should properly be integrated with the AI, with the Android application which is using the same Wi-Fi or is in the same subnet. Okay, your port should be properly configured. Your application should be properly configured to access those ports. You should take care of that. Your networking should really be pretty solid about it, about running these models. And even if you don't know a lot about networking, you can learn about it. Okay. I do not mean to discourage you. You can still apply for GSoC. You can still learn along the way. Networking is not something very difficult. You can learn it along the way. Next slide, please. Okay. Dockerize your agent. Now that you've made an API, okay, now that you've done all the things, now that your model is running, now you have an API as well. You have to Dockerize your agent. You already know the meaning of Docker Hub. You know the meaning of Docker. You just simply use a Dockerfile to Dockerize your model and the API. And when Docker comes into the picture, the networking also becomes a bit complex because see, there are a few things you should take care of. See, mm, when you are trying to run a model directly on, let's say, WSL or a VM, the model might run properly using your GPU. But when it comes to Docker, what might happen is, see, Docker is not pre-configured to use your GPU. Okay, so what you have to do is you have to the solution I found for this is installing the NVIDIA container toolkit. Okay, now there's a link to it. I'm not sure if I pinned the link here, but if you want, I can just give it to you. Uh, Please again ping me for that on Discord. I will give it to you. Or you can just simply search NVIDIA Container Toolkit for Docker. Simple as that. And you will have to do that for Rocky Linux 9.2, which I mentioned again. Okay, and ask me for help if that happens. Even if I'm not your mentor, I will help you. It is pretty simple, and I think I will be able to help you because I have experience with it. So please feel free to ask me if later on if that problem occurs. Okay, next slide, please. Okay, so now the presentation is done. Now I hand over the mic to Sidharth, wannabe contributor.
Hi everyone.
Thank you very much, Vedant. 1 second, Sidharth. Thank you, Vedant, for your presentation.
Thank you.
Let me clarify, just maybe we start the questions and answers. Let me open my camera. My camera is here. Hello, and there. So, talking about the models, remember that in every project idea we have in our main document, it's specified what model you have to use. As I said at the very beginning of this streaming, we are going to be focused on the Google models, both Gemini, accessible by the API, or Gemma, running on the local artificial intelligence server. We can use other models, as you were presenting, Vedant, and as you explained very well. The models are usually trained with specific data or for specific uses, and depending on the uses that the different projects we have this year, maybe we can choose other models. But if we can, we are going to be attached. We are going to stay attached to the Google models, Gemini or Gemma. Okay. This is something I wanted to say. And in every case, as I said, in every project, it's specified what model we want to use. And if it's open, it will say you can choose another one. But if not, you have to be attached to the model that is on the document of the proposals for this year. Okay, so Sidharth, it's up to you. Thank you very much, Vedant.
Hi everyone, I am Sidharth Mugil and I will be presenting about Gemini model, and I will give you a brief what is Gemini model and what is it is made upon of. So before understanding about Gemini model, we have to understand what are MLLMs. So MLLMs are multimodal large language models. So it is bit different from large language model because large language models are only trained on textual data and can only generate text textual data only, but multimodal large language models can generate multi type of data like text, images, audio, as well as videos, and they are also trained upon multimodals. So in MLLMs, they are trained on multimodals. The multimodals can be syntax like code syntax, and the geography can be another model, text data can be another model, images can be another models. So these can also help to understand about the context of the prompt entered by the user more, because as they are trained in multimodal manner, they can also reproduce result in multimodals, so they are more human like and more efficient than previous LLMs, and they can also give resources from different types of data. So like if you have used the chat GPT, so it is only the LLM, but if you have used chat GPT 4, so it is MLLM. We can also generate data from that. So can you please go to next slide? So now let's understand what is Gemini. So Gemini is a family of MLM. So it is developed by Google DeepMind. Google DeepMind is a research laboratory which is a subsidiary to the Google, and it is also a successor of previous Google AI models like Lambda and Palm 2, and it also replaces the Bard AI web app where you can like uh, we can interact with the Lambda model. So Gemini consists of three models. One is Gemini Ultra, then Gemini Pro, and Gemini Nano. So it was announced in 6 December 2023, and it is a major competitor to the OpenAI's MLLM GPT-4. So the main capabilities of Gemini's AI are like it can assist with writing, it can like develop images or like generate images, and it can have better understanding of the context you have asked, and can give answer based on the all the prompts you asked before also, so that it can give more accurate results. It can also generate images on demand, and it can also like brainstorm idea, like if you want to decide a company name for your new startup, we can ask Gemini and it can help you. uh, can you go to next slide please? So in this slide. So one major advantage of Gemini over other LLMs are that as Gemini is developed by Google, so it has better connectivity. Like it can connect to Gmail, Maps, YouTube, and it makes the thing more easier and faster. So like in ChatGPT, we if we want to like search for anything, it cannot give any YouTube link or Maps link. But in Gemini, it it have data, and it has like latest data, and it can connect with the Maps and YouTube. If you can have seen, like if you ask anything in Bard or like now Gemini, it can give YouTube links to that particular answer also. So there, as I talked in previous slide, there are three models in Gemini family. One is Nano, then Pro, then Ultra. So currently the Bard is replaced by Gemini Pro, and we are using Gemini Pro only. And if we pay for the advanced version, it will use Gemini Ultra. But Gemini Ultra is currently in beta stage, but it will be like be in stable stage after some time. So Gemini Nano is like most lightweight model from Gemini, and it is used to design to integrate in mobile phones or web apps, so it can like run and run also give a balance of like not take too much computational power from the device. And then there is a Gemini Pro. So it is a balance between Gemini Nano and Gemini Ultra, and it is a direct like competitor to the GPT 3.5, and also capable in 6 different benchmarks. So when we compare different LLM models, we compare using different benchmarks. So benchmarks can be the parameter size, the amount of training data, and like the reasoning skills, and many other benchmarks categories. Then there is Gemini Ultra, and it is the highest tier model. And if you have seen the trailer of the Gemini, so the trailer was of the Gemini Ultra itself. It can generate uh, any answer from the video itself, and it is very much skill is like successor, and can compete GPT-4 in every benchmarking models. So you can also see in like image in the right, it is for the Gemini Nano model. As we can see that the Nano model is running on the Android SDK and on the TPU accelerator. Uh, can you go to the next slide? So now I will tell you what is the need of Gemini model, like how can it be beneficial for us. So the first and most benefit for the LLMs are it increased our productivity. Like it can streamline our workflow. Like if for like company HRs, if they want to uh, send a email to employees, they are like weak in English, and they don't know what to write, they can simply tell the context of the like email to the Gemini and write a simple prompt, and the Gemini model will generate an email for the HR so that he or she can use it. Then Gemini and or other LLM model can like give personalized experience as well. It also like learn from the previous prompts and results, and give the next answer based on the user previously like personalized experience, like how user wants the answer, how what user wants, and other thing. Then one of important thing is that by Gemini we can access all the internet knowledge in faster and much reliable manner. uh, as we previously used to like search many different Wikipedia articles, or for any errors we used to search for Stack Overflow, and if there is no result on Stack Overflow, we have to ask for question and wait for any contributor to give answer. But after the Gemini can like give answer based on the previous answer, and can re- can generate result for your particular portion only, whether it is available on the internet or not. Then it has also much more social impact, like it can help in education, healthcare, and scientific research. Like we have also many project idea for the liquid galaxy, like tourist, that has also social impact. uh, can you go to the next slide? uh, so that was it for my side. Now mentor Victor will say.
Thank you, Sidharth. Thank you for your presentation. Um, and as you have said, Victor is not here, and as you have said, Sidharth, this year we have plenty of projects related to AI, because this year is the, I would say, the boom of the of artificial intelligence thing. So, and I can say, we cannot share the numbers with the officially with the contributors, because we don't want to have a fight between them before the GSoC is communicated by Google in May. What are going to be the contributors this year? But I can tell you that I will say that 50% of people that are presenting proposals are doing it for artificial intelligence. So, and not as other years that we have many different kinds of artificial intelligence. We have done projects related to taking care of vegetable diseases, taking a look at images, or doing working with in agriculture, doing things with images. But this year everything is going to be LLMs. I think that's sad, because artificial intelligence is lots more than LLMs. But this is the hype this year, and this is where we have to work. And let me tell you also, Mentor Alfredo, I'm not sure he's not here because he's working, but in the next session that Mentor Alfredo will be giving you all, he will explain possible use cases for the projects we have for the Liquid Galaxy today. And you have, Sidharth, added a very good point. Gemini models are multimodal. Gemini models are multimodal, so you can work with text, but you can work with images, or you can work with sound. So Alfredo will be presenting some very nice use cases for using not words, but sound and images for the Liquid Galaxy. So stay tuned. And now, thank you, Sidharth. You can switch off your camera. And now we have Victor Carreras. Thank you very much, Victor. And
no, thanks for you.
When you need to have the slides change, just tell me, okay?
Yeah. Okay, thanks. All right. Yeah, now the point is to know how to use, or to review together how we can connect with these Flutter Gemini with Flutter technology. And for that, this is a really good tool that we have. And Google Generative is a tool that we have. This is created directly from Google team. The publisher is google.dev. And the things that we can do directly is, as I'm saying, generate text from text only inputs, generate text from text and images input. This is the multimodal, what my colleagues were talking about, and build multi-turn conversations like chat. Well, there are more for embeddings and other things, but I guess with all of those three are a really good one approach. Okay, first of all, go ahead go to the next, please, slide. Great. Okay, all right. First of all, what we need is we need to get an API key. The API key, to do that, we have this QR code to go to ia.google.dev/tutorial/setup. And then what we can do, or what we see is a page where you can directly to get this. Well, if you press to the bottom to the get an API key, if you don't see, if you reach, well, go ahead to the next slide, please. All right. If you press it to the get an API key, and you are seeing unavailable languages and regions for Google AI Studio and Gemini API, that means because Google AI Studio is not available in your region, or you don't meet the age requirement plus 18 for access. The point is, there is at this point the list of available languages. Go ahead to the next one, please. Okay. There again, this is the list of the regions where it is available. There is a really long full list. Also the PAL API supports only in English. Using the other language may produce unexpected results. This is what the documentation says. So, okay. As you can see, well, the list is a really long one. Go ahead, please. Yeah, as you can see, okay. All right, but what is the point? The point is, all right, we have access, maybe because you use a VPN. Multiple college I have here in Europe using a VPN to get this API key in order to test or to use this API in order to use Gemini. All right. So now we have this. First of all, you need to know the prerequisites, the requirements have to be Dart 3.2 or more above. The point is you need the latest capabilities of the language. All right, to install, okay, the SDK, well, with Dart, POFAD, Google Ad, Generative EA. With that, you will get in the pubspec.yml. But the point, initialize the generative model. That is what we want, right? Yeah. First of all, now this is a really simple code where we can directly, well, we have the API key in the platform environment. This platform environment is because it is as an environment a variable, because keep in mind we have to avoid to have this kind of API keys inside of our code, because most of us are collaborating in open source projects, and this is something really bad if we share with and also this is something that some of us have seen with Gemini API keys public accidentally in other shared for all of us in GitHub and or public repositories. Anyway, the point is for text only inputs. This is the second command line. The second comment is for text only inputs. Use the Gemini Pro model. And this is what it's doing, creating this object generative model. We can say the model that we want to use as a string and the API key that we got. Then you have to send the content. This is the message that we want to say, and we got the answer, the response after this await calling the model.generate content, sending this content, this array, because content at the end is an array of content. And what we are doing is print response.text, but we can do multiple things using this. Also, just as a note, keep in mind the Gemini API also supports streaming for streaming. So we can use streaming for faster interactions. Okay, go to the next one. Slide, please. All right. But as Andrew and Sidharth was talking a couple minutes ago, only text is not the only thing that we can do. We can generate text from text and image, input multimodal. This is something great because as you can see, the model, this is the part that it was a bit different to the previous one. Now it is not just Gemini Pro, now it's Gemini Pro Vision. So you can input both text and images. When the prompt input includes both text, this is what we need to use. And have a look. This final, it's getting first image, second image, just read as bytes from a file. We have image 0 and image 1 GPGs. Yeah, then what we do is just a text part, because this is this is the way that we use for this kind. For example, this part of code is going to ask what is the difference between these pictures. So first of all is load the pictures. After that, create data parts, because we will send the pictures as a part of a big request, because we are going to send multiple data. And then what we do is we have an array with image parts, because every image is a data part inside of image parts array, and we have text part in the prompt variable. So where has our request or what we want to ask to Gemini. So what we do is again call model.generate content, because this is what we did the same. And inside of this array, we are gonna put a content.multi, and inside it's gonna be prompt and image parts. The point is create an array all together, like a mix of those elements inside of an big array. And then we will get again the answer in the response.text. And this is where we can catch the answer. Okay, go to the next one. Again, we can use streaming, but for me, streaming it is something a bit different because, well, the use of streaming for faster interactions by default, the model returns a response after completing the interior generation process. But sometimes it is a delay, like the user experience is it could be affected by this because sometimes the generation process is bigger than expected, depending on the kind of request that you are doing. So big approach is to use this streaming, and you can send like content multi that we were doing before and generate content to ask into the model. But something that you can do is inside of the response, you can using a for, you can a for loop. We can iterate by chunk, printing the text of the partial results. So this is something, and this is called a faster interaction, and this is something that you have to keep in mind that you can do because the Gemini API is supported. Building multi-turn conversation, I mean a chat. This is something available to using Gemini Pro. If you want to do this, the narrative model again, with this kind of model, Gemini Pro and the API. But now what you have is this generation config. These max output tokens. This is, again, where you want to initialize the chat, model start chat. And inside of the history is an array of content that you have to send things like, for example, hello, I have 2 dogs. This is a content text. But inside content, you have a content model with an array text part. Great to meet you. What would you like to know? And then you can add a new content. How many paws are in my house? And you can use this chat. Keep in mind, we use a start chat instead to use the other previous one that we use, generate to the model generate content. Because to build a multi-turn conversation like a chat, you have to initialize it. Uses a start chat. Start chat is the way, like the status of our chat is, and we use send message to send a new user message. Will also happen the message and the response to the chat history. So that's the point, because sometimes you can restart, or you want to restart in a point where you had our conversation and you don't have to restart again, because maybe you have storage the point that we were, and you can load the point that you were using this history, and we use text to continue asking something. And keep in mind, because this model, content.model, is the role which provides the response. This role can be used when calling start chat with existing history. That's the point. The point is this: you have to address with text that the text, the content.text is comes from the user, but the content.model comes from the role which provides the responses. So this is something that you have to keep in mind, because if a different role is passed to the user, you can throw an exception if a different role is passed. So this is something that you have to keep in mind if you are playing with this at the beginning and you start to receive unexpected exceptions or unexpected behaviors, that you have to keep this in mind. So one thing else, the Gemini provision model, because if you see, we are using Gemini Pro instead to Gemini provision, because the Gemini provision model is not yet optimized for multi-turn conversations. So that's why we use Gemini Pro with text-only input for chat. And yeah, I think, okay. All right, this is what we were talking before. By default, the models returns a response after completing the third generation process. This is what we did before. If you see the generate content with if we want to use a stream instead to wait for the final or the delay after a long time of the process can take, you can get partial results and like these faster interactions. And the way that it is doing is, like you can see, is an await for final chunking response. That's what it's doing. Is as soon as I'm starting to have partial states, you can be addressing properly one by one. Okay. Yeah, that's all.
Thank you, mentor. Please, Sidharth, Vedant, if you are there still, it's gonna just share a few minutes because I still don't see any question in the YouTube chat. Let's hope that these guys have any question for us. Thank you for your presentation, Victor. There has been a slide that I like a lot. It's the slide where you talk about the APKs to be published in a wrong way. So this happens before and will happen in the future.
Yeah, multiple times. I never tried to talk about it because always I have a close histories from someone where it does in a short time. So this is happening like a loop.
Pablo says thank you, Victor, good explanation. So there is let's make a little bit of time and also not too much. If people have no answer, we will end here. But it's been something like 1.5 hours. But also because we have another streaming training today, it's crazy. Mahinur will be with us in 30 minutes. She's gonna be making a training on building a virtual Liquid Galaxy rig. And today is a crazy day. But my anecdote is that there is some kind of old technology that was called DVD. You know, Sidharth and Vedant, what a DVD is? Yes.
Yes, we do know that.
Of course, it's not as ancient. No? So the point is that at certain moment, the keys. Manas has a question. I was facing some errors trying to fine-tune a Gemma model. Can you suggest some resources? I don't know if any of you can answer this question. Gemma is a very new thing. Go ahead, Dan.
So fine-tuning a Gemma model would probably be similar to that of fine-tuning a normal LLM. So you can find a lot of resources on YouTube. I do know a video. I will forward that video in some time after the meet on the Discord channel on setting up how the Gemma model locally. And then,
Good.
yes, that's a.
Thank you, Amit. Thank you, Aritra. And let's wait for a second. I was talking about that when the industry launched the DVD, the moving picture companies, the companies that does the production companies that does the movies, didn't want to use the DVDs because they think that people is gonna copy their movies and not going to the theaters, and then the industry implemented a secure key and encrypted all the data inside the DVDs with a secure key, and then this is not possible. You cannot break the key. So all the industry was making DVDs, but suddenly one developer of one company that does a DVD player in software released the key of the DVD compression, the DVD encryption on a public place without him to know. So suddenly everyone is able to get the key and decrypt all the DVDs. So then suddenly everyone was able to pirate a DVD. This was a crazy moment. Just for leaving a stream of, I don't know, 15, 24, whatever number of characters. It was a long stream, but only a string of characters. So please follow Victor Carreras' slide about please be careful with your API keys, because if not, you can have very funny moments. Okay, people from the YouTube chat, anyone other question? If not, we are gonna close the session. It's been exactly 90 minutes, and we have another session here in 30 minutes with Mahinor. So 1, 2, 3. I will wait for a few seconds. In the meantime, thank you again, Victor, Sidharth, Vedant. We'll see you in some other streaming soon. And Sidharth, be the force with you, man. Work a lot.
Yes, I will work.
I know you do. I appreciate your work. So there is no more questions. So people, thank you, Ryan. And thank you to the two guys that have taken notes of this session that will be published on our website as always. So thank you very much. Take care. Bye bye.
See you guys. We are in touch.